Hey everyone, welcome. My name is Nithin Rao. I'm the CEO and co-founder of SkySQL, and I'm here today with my co-founder Jags Ramnarayan, who's our CTO. And we want to share with you what what we've learned building for the new wave of AI apps, what we feel is working, what's not working, where we think things are headed. So I'm just going to spend a few minutes up front on who we are, what we do, and then I'll turn it over to Jags. So one of the big challenges that we see is that as AI agents and LLMs get built more into apps, people want natural language answers that combine semantic and structured search. But making that work is actually pretty hard. So with SkySQL, we integrate vector search along with agents into the database in order to deliver on hybrid search. So just a quick bit on who we are. So our background is in building large-scale cloud database platforms that run some of the world's largest companies. SkySQL actually spun out of MariaDB a couple of years ago, and our core engineering team is the same team that built MariaDB's cloud and distributed technologies. We've got decades of experience building large-scale fault-tolerant data platforms, and what we're focused on these days is how these operational databases are evolving for the AI era. So many database platforms today are becoming AI ready by bolting on a vector DB. And while vector is a critical component, it's just not enough, right? AI agents lose context. They deliver inconsistent results, especially with structured data. And so you really need a unified platform that natively supports vector search and gives agents direct, reliable access to data. And for us, that means multi-engine serverless with built-in agents. So the right engine handles each workload and the answers stay accurate and consistent. So what does this look like in practice? So we've built an AI semantic engine right into the database service that can answer complex questions reliably and at scale. So the developers don't have to wire together multiple services or build custom connectors. Instead, you can leverage a simple API that speaks natural language. And the database decides whether to run a transactional or analytical query or a vector-based semantic search under the hood. So our approach is really to unify best-of-breed engines, operational DB for OLTP, vector engine for similarity search, and analytics DB for large-scale querying, and all orchestrated with serverless infrastructure. So these engines provision and scale instantly and independently. And so developers can move much faster and save on operational costs and get accurate answers grounded in data. So this saves months of development efforts, reduces system complexity, and it increases the accuracy and predictability of AI-driven apps. So you typically hear about vector databases as a tool for semantic search, really over unstructured data, so things like documents, images, audio, etc. But for AI agents to be really useful in enterprise settings, they need to do more than that. They need to answer specific business questions and generate reliable results grounded in, the company's structured data and not just unstructured content. So that's only possible if the vector layer is actually aware of things like the tables and columns and relationships, business logic, the full sort of richness of structured enterprise data. So it's not just about adding vector capabilities, but it's about fusing vector search into the database itself so that agents and the data, work together natively. And so with that, I'll hand it over to Jags, who will dive deeper into how we're leveraging vector search to deliver on this vision. Thanks, everyone.
Hey, thank you, Nithin. Hello, folks. I'm Jags Ramnarayan. I'm the CTO for SkySQL. Before I dive into how we support agents in the database tier, I thought I'll spend a few minutes just talking about the most common patterns or approaches folks use for natural language conversation with the relational database. Up until last year, the most frequently touted pattern has been the RAG pattern, the Retrieval Augmented Generation pattern, which was created by Meta. It actually was a seminal paper in 2020. The pattern is rather straightforward, right? So in this context of working with databases, you essentially take all your database metadata, schema information, what have you, store it as embeddings into a vector store. Incoming user question results in a semantic search, so that you're drawing out just the context you need. For instance, show me the top 5 tables that are closely related to the question the user is asking. You take that along with the user prompt, send it to the LLM, generate SQL, take that SQL, run it securely on your database, and out comes the result, right? Rather straightforward, and you'd use a framework like LangChain, Llama Index, Vertex AI, that sort of thing. But from our standpoint, there are lots of issues, right? Typically, the terminology used in schemas, right? Table names, column names don't match up to user terminology. There are hidden semantics, relationships that tend to be missing. The end result is that you have a lot of hallucinations, and the actual accuracy of such a scheme is really, really low, right? So fast forward to this year, and the rage is really all about agents, specifically domain-specific agents. A number of definitions are there for agents. From my standpoint, there are four key characteristics. One is agents are about being very task-specific, goal-oriented. More narrow your task and narrow your scope, the better the agent's accuracy will be. Agents are all about the ability for it to reason with much more complex questions, decompose, break it down into steps and tasks, and execute it in a certain sort of order based on the context it's got. It can use and connect LLMs to external data sets. That's where tools come in, so that you can take custom actions. But perhaps the most relevant capability from my standpoint is ability for it to self-reflect. So as it's going through a sequence of tasks, maybe it lands up in errors. Maybe the SQL syntax that was generated was wrong. So the ability to self-correct itself is really a key aspect of agents from my standpoint. Here's a quick example. I won't delve into it too much. This is based on the DBA agent that we package and provide inside our product. So maybe a question could be like, hey, analyze the top 5 slow queries and give me some very specific optimization suggestions. The agent might decide to come up with some steps that I'm outlining. Now, one thing to remember with agents is that they're indeterministic by nature. They're intelligent. Given the context, given its actions, it determines the steps dynamically. That's the key part. So maybe the steps are like, hey, slow query going on. Is it to a table? If so, can we find the top 5 queries? Oh, I got the queries. Can I do an explain on each of these? What are the results of the explain? Can I use prior LLM knowledge to figure out, some specific optimizations we can do? So that could be the journey it takes. All along that journey, it's constantly using the tools we provide. In this case, the ability to run SQL securely on our database, return back the right results, so it can reason with it and continue looping through it. Okay. Now you might be wondering, folks who are aware of agents, well, most of the popular frameworks, whether it's LangChain, Amazon Bedrock, Llama Index, Crew AI, all of them provide support for agents in fairly, very sophisticated way. But when it comes to actually having agents work with your enterprise databases, there are lots of challenges. It's complex. There are security issues. There are data consistency. I'll just highlight a few. So as an example, let's say I'm managing, I have to now take sensitive sort of data samples, metadata, and manage it in a vector database that's perhaps outside the database. Well, how are you going to manage that sensitive data? Now, all of a sudden, you also have copies of a schema sitting elsewhere. Well, what happens if the schema is changing? How is that going to be consistent, right? And the important other aspect is that agents actually have a notion of short-term and long-term memory, essentially session state and stuff like that. Now, it could also be sensitive data there, right? Because you're asking questions, responding answers are sensitive data. Lots of issues to grapple with. And the end result is that even if you do that, you have tremendous complexity, and quite often the accuracy is still low. So from our standpoint, this is our take. It's really important that you have clear separation of concerns. When you're designing your agents for your application, focus on workflow, orchestration, guardrail issues, and simply create separate agents on the data tier itself. From our standpoint, these agents should rely very close or operate very closely with the database, so they intelligently understand the structure, the schema. They always keep consistency things in mind, things like that. In a way, it's analogous to how SaaS applications have a data access layer, or when you're dealing with complexity in terms of queries or logic, you land up running it on stored procedures. So we look at it very similarly. So what's our actual solution? We use we call it Sky AI DB agents. Few characteristics. One is that it's an opinionated solution, not a framework like a LangChain. So it's a no-code solution. So if you're an analyst who understands, a business analyst who understands the schema, the relationships, the data fairly well, off you can go. You don't need to do any coding at all. It semi-autonomously generates the right context, the semantic context that really lends itself to higher accuracy. We always say semi-autonomous because human in the loop is absolutely important. So through our UI, the human in the loop here, the expert can now tweak, train those and adjust the semantics really well. And it's also rather important to be deterministic in this case. And what I mean by deterministic here is that if you come up with a response to a question, how do I now know how good is the response? So we have an inbuilt evaluation scheme that always avoids false positive. What that effectively means is that if we tell you that the answer is really with high confidence, it's correct, it would be correct. So here are some attributes. Like I said, we automate the entire pipeline, the RAG pipeline. So the automation is built out of the box using EUI. That's kind of how, and I'll showcase in a second here. Using UI to generate the context. Like I said, the domain expert now tunes it, adds semantics. And once you've trained it enough, you essentially click a button, publish it, and it gets exposed as REST API. And what that effectively means is your application level agents now simply use these database level agents as tools, and off they go, right? We manage consistency, and then, as I said, pointed out, online evaluation is a big part of what we do. This is just a very quick architecture diagram. I'll just make a couple of points. The agent engine itself that we kind of built for you is all based on Llama Index. It's highly scalable. It operates in a secure domain. It can use a variety of LLMs out there. And of course, it can work with data sources that are internal to how SkySQL manages databases, or it can also be external. All right, with that, let's just get into a demo. The example I'll use is retail inventory optimization. Now, let's assume that your application agent wants to optimize stocking level for a whole bunch of retail stores. Now, as you can imagine, if it's intelligent enough, it might be coming up with questions like, can I analyze the historical stock levels for certain products, right, that sell really well? Maybe there are products that have seasonal variations, so might want to look at seasonal demand, promotions, so on and so forth. And these are questions you want to send and route to a database agent that now has access to all the relevant contextual data, right? Inventory data, sales data, seasonal patterns, so on. Right? It could be hundreds of tables. So how does it work? So let's actually take a look. All right. Okay, so what you see here is our UI or portal. There are sort of built-in agents. I won't get into that. Developer agent that's built in, allowing you to do SQL, DBA agent, things like that. So what we are interested in creating a custom agent for the inventory optimization. So it's a very simple process. You could create, and the main thing here, I won't actually create it because I already created it. You pick the data source, and the most relevant thing, like I pointed out, is that you specify the intent, the scope precisely. If you can hint on the data sets that are very relevant, that also helps a lot. And then when you click next, we go through a sequence of things to generate the context for the table. So let's actually take a look at it. Oops. So here is our agent. I've pre-created it. So let's actually click edit context. And as you can see, this is what the user essentially has provided, in this case, me. Essentially, I'm telling the fact that this agent is about demand forecasting, inventory tracking, and price optimization so we can reduce stockouts. And I've also provided it the data sets that are really relevant, right? Sales data, inventory data, pricing, and promotions. Okay. And when you click next, essentially, this is where we go through a process of discovering which tables are relevant, which columns are relevant, so on and so forth, and generate the context. So in this case, I mean, there are only 4 tables, so it's selected all the 4 tables that are relevant. But for each table, as you can see, we have used AI, generative AI, the LLM, to actually synthesize a quick synopsis of the semantics of this actual table itself. In this case, selected all the columns. Of course, you can deselect, add column description, that sort of thing. We might also inject sample rows into the data set if it's appropriate. One other interesting thing you notice is that there's a column called semantic index. This is where it becomes really relevant to make sure that some of the data pieces, especially categorical values, that get used in filters, right, in where clauses and filters inside the generated SQL, we can actually vector index those. So we actually detect such columns by looking at the cardinality of these sort of discover categorical columns, discover the cardinality, and then we take those columns and auto-index them. right? And that's what shows up as semantic index, and we'll see how it gets useful. All right, so let's try out a few quick questions. Let's say we want to sort of look at Zara as a retailer, and we're interested in saying, which products are at a risk of stock out. As you can see, it generated the SQL that's a join query. We always show you the SQL. All these results are returned in a structured format if you're using the REST API. And the reason, obviously, these are products that are at a risk of stock out is because the reorder point is greater than the stock level right now that we have. So Zara looks like it's got a number of products that are at a risk of So let's try a more complex question, right? So let's say we want to compare how Zara from an inventory turnover standpoint compares to H&M. And here, obviously, the agent is smart enough to sort of figure out saying that, hey, you know what, I need to do a computation to figure out the actual inventory turnover. So it's actually dividing sales quantity by the stock levels. And as you can see here, it turns out that H&M, its competitor, actually has a significantly higher turnover than Zara, right? So you can go on, right? You can continue the conversations, ask more complex questions, so on and so forth. Let me ask one other quick question that highlights the use of sort of vector database that I mentioned before. So let's say which Apple products now are at a risk of stock out. And the thing I want to point out here is if you see the question itself, he just said which Apple products. And if you look at the actual where clause, it says the store name is Apple Store. So this is where I was mentioning how we essentially index categorical values. They automatically get injected into the context to the LLM becomes very, very relevant. There are other things like you can mark as you kind of go through this training. If you find that these are questions that are correctly answered and they're relevant to your users and stuff like that, you can simply start to mark it as a golden query. The golden queries, you could have 50, 100 golden queries, especially for complex agents, and they essentially, again, improve the accuracy of the results. And even the golden queries, all of this essentially lands up going to the vector store, okay? And then there's an evaluate button that if you want to evaluate to sort of find a score for the accuracy, we use LLM as a judge also behind the scenes to score things on relevancy and faithfulness and things like that. And we provide all those scores back to you if you're using the API. Okay. All right. So let's now go back to our deck. So what's going on behind the scenes? I'm not going to go to the details. It's a very cursory high-level view. I'll highlight where are we using the vector database, right? So initially, when you express the intent, the builder agent or the agent builder, if you may, essentially has sniffed out the entire schema, information, foreign keys, constraints, what have you, into the vector database. It looks at the intent and figures out which tables are the most relevant. Likewise, behind the scenes, once you have tuned the essentially semantic descriptions for the tables, what have you, we also, like I said, we sniff out all the categorical values and we pump all those categorical values also into the vector database. So essentially, a lot of this is in the vector database, including the golden SQL, right? So now once we have it in the vector database, most of the context, how do we land up using it? So this is sort of the general flow, high-level flow of, take a user question, turn it into an embedding, we search for the relevant tables. Again, using semantic search, we also look for the relevant categorical values that could be relevant to the question at hand. And we inject all that along with, actually, I should say, golden SQL into the agent context. So the agent context is tied, less tokens, the most relevant information is extracted, provided the context. And the agent then goes through a looping process of reasoning with the question, breaking it down to a sequence of steps. And for each step, we generate the SQL statement using the LLM. And then, of course, we have enough guardrails so that it securely executes it. And we also have optimizations, like, for instance, the agent could have come up with 5 steps to do, or we could have discovered that right after step 2, we actually have the answer we're looking for. So we can terminate the agent's processing, provide the answers, faster results, less tokens. That's what I'm. I just want to make one important point about, on vector databases. So we landed up using MariaDB Vector, not just because we come from MariaDB, of course, we're predisposed to MariaDB, but also because MariaDB's performance is really, in some sense, the best in the industry from the benchmarks we have seen so far, right? From the ANN benchmarks, that's the results that you see here. This is just comparing sort of MariaDB vector with PG vector. And what you see on the x-axis is the recall. Recall is more, think about it as the accuracy level of the approximate searches that you're doing on a vector store. The recall is 1, that effectively means on any search, the vector database returned all the nearest neighbors back to the user. So effectively, it's as accurate as it can be based on the data that the vector store has got. So you obviously want all your data points to be on the upper corner, the highest sort of throughput at the best possible recall, right? But as you can see here, MariaDB Vector is like, I don't know, 2.5x better than PG Vector on the CNN benchmark. So that's one of those big reasons why you pick MariaDB Vector. All right, so I'm just going to leave you with this parting thought, which is that if you're building sort of agentic apps, chat applications, I highly encourage you to think about database interactions in an intelligent way. Don't hard code your SQL. Use agents that are very specifically designed to work with databases really well. In our case, we actually package these database agentic behavior inside our serverless database. We have a perpetually free tier serverless database that's based on MySQL MariaDB, runs on all clouds. It comes with AI agents, and there is a generous amount of free tokens that we provide. So I encourage you to try it at app.skysql.com. And thank you very much.